Hello everyone. In the previous video we learnt about the solution of question number 1 to question number 12 of exercise 7.2 based on integration by substitution. We are continuing the next part of it in this video, that is question number 13 onwards. And question number 13 here is integral of x square upon whole cube of 2 plus 3x cube. What is to be considered as t? Here we find that 2 plus 3x cube. We know the derivative of x cube is 3x square and derivative of 2 is 0. It means if we consider this particular function as t, then the integral will become easy. And we are doing that. Let 2 plus 3x cube equal to t. Differentiating with respect to x, we find here 0 plus 9x square dx equal to dt. Simplifying this, we can get here x square dx equal to dt upon 9, because here we have got only x square into dx. Substituting that here, we get 1 upon 9 into x square into dx dt, and this is 1 upon t cube. We can write this as 1 upon 9 t power minus 3, and we know that integral of x power n dx is x n plus 1 upon n plus 1 plus c. Applying that here, we will be getting t power minus 3, so this will become t power minus 2 upon minus 2 plus c. We can write it as minus 1 upon 18. T power minus 2 means 1 upon t square, and substituting a value of t, we are getting 1 upon 2 plus 3x cube whole square plus c, which becomes the answer to the problem. Question number 14, we have integral of 1 upon x into power m of log x. To think for t here, we have log x, and we know d by dx of log x is 1 upon x, which is available here. So we can take log x as t. So we write let log x is equal to t. Differentiating with respect to x, we get here 1 upon x dx is equal to dt. And if we substitute that here, we are getting 1 upon x dx will become dt, and this is 1 upon t power m. We can write this as again like this. This is t to the power minus m. And applying the same formula here, we get this as t to the power minus m plus 1 upon minus m plus 1 plus c. We can also write this as 1 upon minus m plus 1 into 1 upon t to the power m minus 1. Substituting the value of t, we get 1 upon minus m plus 1 into 1 upon log x power m minus 1 plus c. This is the answer to the problem. Question number 15 here is integral of x upon 9 minus 4x square. And we know derivative of x square is 2x and that of 9 is 0. So we can consider this particular function as t. So we consider 9 minus 4x square as t. Differentiating with respect to x, we are getting here 0 minus 8x dx is equal to dt. To find the value of x into dx, we are getting this is minus 1 upon 8 into dt. Substituting that here, we get minus 1 upon 8 dt upon t. And we know the integral of 1 upon t is log t. So we can write this as minus 1 upon 8 log of t plus c. Substituting the value of t, we get minus 1 upon 8 log of 9 minus 4x square plus c. This is the answer to the problem. Question number 16 here is integral of e power 2x plus 3. Exponential function, and we can easily make out that 2x plus 3 can be considered as t. So we consider 2x plus 3 as t. Differentiating with respect to x, we get here 2 plus 0 dx is equal to dt. And hence we get dx is equal to 1 upon 2 dt. If we substitute this value here, we get 1 upon 2 e power t dt. And we know the integral of e power t is e power t only. So this becomes 1 upon 2 e power t plus c. Substituting the value of t, we get 1 upon 2 e power 2x plus 3 plus c, which is the answer to the problem. 17th question here is integral of x upon e power x square dx. We know derivative of x square is 2x dx. So we can consider x square as t here. So we write let x square equal to t. Differentiating with respect to x, we get 2x dx is equal to dt. It means the value of this x dx is equal to 1 upon 2 dt. Substituting this value here, we get 1 upon 2 dt upon e power t, which can be written as 1 upon 2 e power minus t dt. Integral of e power minus t will be minus e power minus t, because minus 1 is multiplied here. So we get here minus 1 upon 2 e to the power minus t plus c. Can we write this as minus 1 upon 2 e to the power t plus c? Substituting the value of t, we get 1 upon 2 e to the power x square plus c, which is the answer to the problem. Question number 18 here is integral of e power tan inverse x upon 1 plus x square. And we know derivative of tan inverse x is 1 upon 1 plus x square. So we can consider tan inverse x as t. Considering this, we write let tan inverse x is equal to t. Differentiating with respect to x, we get 1 upon 1 plus x square dx is equal to dt. Substituting here, we get this as e to the power t dt. And we know integral of e power t is e power t only. So this becomes e to the power t plus c. Substituting the value of t, we get e to the power tan inverse x plus c, the answer of this particular problem. Question number 19 here is integral of e power 2x minus 1 upon e power 2x plus 1. Here if we take this as t, the derivative of this will not be this, because minus 1 will not come. And hence we have to divide the numerator and denominator both by e to the power x, or we multiply both by e to the power minus x. So we write here dividing numerator and denominator by e to the power x. Then this will become e to the power x minus e to the power minus x, or not, because e power x, when it comes 1 upon e power x, that can be written as e to the power minus x upon e power x plus e to the power minus x dx. And now we know if we take this as t, the derivative of this will be this. And hence this can be considered as t. So we write let e to the power x plus e to the power minus x equal to t. Differentiating with respect to x, we get e to the power x minus e to the power minus x dx as dt, which is here. So this can be written as dt upon t. And we know the integral of 1 upon t is log t. So this will be log of t plus c. Substituting the value of t, we get here log of ex plus e to the power minus x plus c. That becomes the answer to the problem. Question number 20, we have integral of e to the power 2x minus e power minus 2x upon e power 2x plus e to the power minus 2x, which is similar to this. If we consider this denominator as t, considering e power 2x plus e power minus 2x equal to t. And differentiating this with respect to x, we get 2 e to the power 2x minus 2 e to the power minus 2x dx equal to dt. If we divide both the sides by 2, we get here e to the power 2x minus e to the power minus 2x dx is equal to 1 upon 2 dt. Applying this here, we get 1 upon 2 dt upon t. And we know integral of 1 upon t is log of t. So this becomes 1 upon 2 log of t plus c. Substituting the value of t, we get 1 upon 2 log of e to the power 2x plus e to the power minus 2x plus c. That is the answer to the problem. Dear friends, if you have not subscribed the channel so far, subscribe it to get more videos on different topics of mathematics. Question number 21 here is integral of tan square 2x minus 3. We know that we don't have any formula for integral of tan square x, but we have that of sec square x, so we can convert it into that. We know tan square theta is sec square theta minus 1, so we can write this as sec square 2x minus 3 minus 1 dx or not. And then we can divide it into parts. This is sec square 2x minus 3 minus 1 dx. We know the integral of 1 is x. For this, we can consider this 2x minus 3 as t. So we can write let 2x minus 3 equal to t. Differentiating this, we are getting 2 dx is equal to dt because derivative of 3 is 0. And hence we get dx is equal to 1 upon 2 dt. So in the first part, we get sec square t dt into 1 by 2 minus integral of 1 here is x plus c. We know the integral of sec square t is tan t. So this will be 1 by 2 tan t minus x plus c. Substituting the value of t, we get 1 upon 2 tan 2x minus 3 minus x plus c. This is the answer to the problem. Question number 22 is integral of sec square of 7 minus 4x. Easily we can say this is a linear function, so we can consider this as t and we write let 7 minus 4x equal to t. Differentiating with respect to x, we get here 0 minus 4 into dx is equal to dt. It means dx will be minus 1 upon 4 dt. Substituting that here, we get minus 1 upon 4 integral of sec square t dt. And integral of sec square t is tan t. So we substitute here minus 1 upon 4 tan t plus c. Substituting the value of t, we get minus 1 upon 4 tan 7 minus 4x plus c, the answer to the problem. We will continue the remaining questions in the next video. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.